Okay, so for example, what is the domain of this function? Well, let me look at the numerator. So numerator domain. The numerator domain, well, what I have is a square root function. So now I realize, okay, the big thing with the square root function is that radicand cannot be less than 0. So I need to figure out what I want. What I want is what input causes this to be greater than or equal to 0. When I solve, I get -1. So for the numerator, that's my domain. I need values that are greater than or equal to -1. What about the denominator? Well, the denominator is a different story. This denominator has all real numbers. So the domain of the denominator is all real numbers. Not a problem here. So the next thing we need to do is figure out what causes this, if anything, to become a 0. So what causes this to become a 0? And the answer is, well, when I solve, it looks like it's 6. So what do I have here? Let's just do this in picture form so we can see it a little better. What I have is that I'm going to take into account the numerator. I could use anything here greater than -1. When I look at the denominator, I can use everything except for 6. 6 is the only thing that I'm not allowed to use. So now, what's common to both? Well, what's common to both? Well, I cannot, for example, if this is which is -1 here, -1 is located here. Sure, this denominator can use values less than -1, but not for the numerator. So these are out. Right? We cannot use these values for the total domain of this function. So it looks like we can start at -1. And I'm chugging along here. We'll common to both, common to both, common to both, and then finally we get to 6, the discrepancy. 6 is no problem for the numerators, but it is a problem for the denominator because it causes to be 0. So I'm going to write 6 and exclude that. Then I'm going to union that with, and I get to the other side. After that, we're paired up. No problems from this problem, this moment onward, and we can go to infinity, and there's no problem. So there's your domain. Let's look at this next example. What is this domain? And now, again, we have two radicals. So we look at these two separately. Denominator. What's true about the denominator? Well, the denominator cannot be, this radicand has to be greater than or equal to 0. But because it's a denominator, this cannot be equal to 0. So for the denominator, we'll just do greater than 0. Okay? Because again, if the output is 0, the denominator is no good. I solve for this. I add 4 to both sides. Divide by 3. And I have 4/3. So that is the domain, describing domain for the denominator, numerator domain. And I have now the fact that, again, this radicand cannot be less than 0. It can be greater than or equal to 0. It's in the numerator, so I can make it equal. Again, I will solve for x, subtract 4 from both sides, divide by 2, and I have x greater than -2. Also, it's a quick reminder, if you divide or multiply during this process of an inequality by a negative, this sign has to be flipped. So a little aside here. For example, if you're trying to solve something like this, and subtract 1 from both sides. This is different. This is obviously not part of this question. So subtract 1 from both sides, get -1. Now you have to divide by -3. As soon as you divide by -3, you have to put the inequality. So that will result in this solution. So this is the SI. You have to flip when you divide or multiply by the negative. All right, we're back to this question. So the denominator has this restriction. The numerator has this restriction. So let's kind of superimpose both of those together. So this one, the numerator says it must be greater than or equal to -2. So I'm going to just kind of hover above it. So I'm going in this direction. What about the denominator? The denominator says, well, I have to be greater than 4/3, 4 and looks like it's 1 1/3. So the thirds are about right here, somewhere there. And I must be greater than it. I cannot be equal to it. And I must go in this direction. So what is common to both? Well, what's common to both is this domain, this what I drew here for the denominator. That's common to both. Otherwise, this is not this is no good. This area right here between -2 and 1/3, 1 1/3, no good. So the domain is what's common to both. So domain of t of x is, again, using interval notation, starting at 4/3, but not including 4/3, just go to infinity.